Hi, my name is Daisy, Senior Technical Product Manager from Layer 2 3 PM team. In this session, I will demonstrate how to run a PCEP test for RSVP-TE RSP. The bottom shows the typical test configuration, and the use case we support today is to test the PCE capability of synchronize existing RSVP-TE RSP. So DUT will be the PCE, and then we have IxNetwork emulating both RSVP-TE tunnel ingress and egress. So the both IxNetwork port will connect through DUT as through another transit node, which connect to the PCE. So both IxNetwork port will have the reachability to the PCE through the transit node. And on the Ingress side, we also have a PCC components running and establish PCEP session with controller through the transit node. So the top here shows NGPF scenario view for this demo configuration. So the left hand is the Ingress side, and then the right hand is the Egress topology. So we also add a PCE components in the Egress topology because we're running the test in back-to-back, and we need a PCE components to be able to establish PCEP session with the PCC on the Ingress side. In the real test, this will be a DUT. Okay, so let's move on to the IxNetwork session here. So as you can see, I already have a 2-port added here, and I will show you the step-by-step configuration to set the demo up. So we will start from the scenario view first and add the ingress port. So I will emulating a transit node within IxNetwork port also. And I need to run IGP protocol to be able to advertise the ingress source address. So I will pick the OSPF here. And I only need one. So now I need to add a cloud, which a prefix pool to for the tunnel ingress, the loopback address, and then I will add another device group behind it for the RSVPTE ingress. And also on the ingress side, I also need to run PCC. So let me add a PCC components here. So that's an ingress setup to make it easy to view on the topology. Let me name it transit node, and then this one is actually the ingress loopback, and then I have this device as a tunnel ingress, and then this overall topology is ingress topology. Okay, after this, let me do some basic configuration. First of all, we need to configure the IP, and so let me do here as 1, and then the other side will be 2. So for the RSVP-TE side, I don't need a specific configuration, just to keep everything default. And then for the OSPF, I need config the network type because I'm running back-to-back. So I need to set the network type as point-to-point. I think that's pretty much. And then move to the ingress loopback. I want to have the loopback address configured as 2.2.2.1 for the ingress, and the increment will be 1. And then I need the prefix. This is a loopback. Prefix will be 32, and I need the 10 ingress here. Ingress node. Okay. 32. Okay, so from 2.2.1 to 2.2.10. Now, from the tunnel ingress side, we first configure the loopback address. Need to match what we just configured in the cloud. Start with 1. and then move on the RSVP-TE configuration. So we have a 10 RSVP-TE Ingress node here, and then for each Ingress node, let me configure 10 RSP, the Ingress RSP, and then I don't need the Egress here, and then from the head end, so I need to configure the remote IP. So let me use I will configure the remote side, but I will use 3.3.3. So I'm going to have one egress node terminating all the tunnel from 10 ingress node. And then we have the tunnel ID, and I want to make the RSP ID to be same as the tunnel ID. Okay, so here you can see we have total, move up a little bit. So each ingress node, we have 10 ingress RSP, and then we have 10 nodes, so we have total 100 ingress RSP here. So the other parameter we can just keep as default. And then one thing to notice here, we have a session name configured here. This will be used as the RSP symbolic name. So we just take the default configuration from 1 to 100. And then you might also want to configure some bandwidth. Let me just configure same bandwidth for all of them. Okay. So one thing on the path reoptimization, so you'll notice here has a backup RSP ID, because if we do the make before break, and then the backup RSP will pick the RSP ID from this number. So let me also change it. So for different nodes, they are different. It's easy for reference. Let's say the first node will have start from this, and then the increment will be 10. So that you can see the backup RSP. So we will use it later. Now on the ERO side, let me enable the ERO. We do want, because for the PCEP, when we synchronize RSP, we need to report the ERO to the controller. So let me enable the ERO. I want to configure 2 ERO here. So then you can see there are 2 ERO subtype shows up. The ERO type can be IP or the AS number. So let me just configure IP address here using. I have all this to the same. Let's do a 3.3.3.1, which is the other side. So they're same. And then the second one, I just use the AS number. So just show you here. Let's say we have 100. Okay, so we have the ERO configuration. Now on the PCC side, if you look at the PCC configuration, so all this other tab, requested RSP, pre-established RSP, and also the expected initiated RSP, they are all for the segment routing RSP. And for RSVP-TE RSP, we do not need to configure all this, because we actually automatically synchronize the RSVP-TE RSP state from the RSVP-TE components to the PCC components. So users do not need to do additional configuration, and all the state change will be automatically reflected to the PCC. So all we need to configure here is the PCE IPv4 address. So I will use the 100.1.0.3 here. So talk to the same PCE. And then you can configure the TCP part if you don't want to use the default part for your specific implementation. And then we have some parameters to control the message bundling. And this is for the PCE response and for the PC report. So for the RSVP-TE tunnel, we will use the PC report here because we need to synchronize the existing RSP. And let me configure this as 5. So we will have 5 RSP in a single PC report message. This applies to the initial synchronization only. And then we have keep alive dead interval. So this is all the PCEP session control timer, and some other fine-tuned session reconnect, and also return the error. So all the other, this is for the segment routing RSP. You don't need to bother with it. Now, besides this, the PCEP session needs advertised capability. So for the stateful RSP update and also installation, you can enable the capability based on your need. For this demo, we do the RSVPTE RSP, so we do not need the SR PCEP capability. I will disable it. And then we also have a rate control. This is to control how fast you send a packet, the PCEP message. So let me just enable, have the default parameter here. And then we also support authentication. So default is no authentication, but we do support MD5 authentication. So that's all you need to configure on the PCC side. So now let's move on to the egress topology. So again, I will first configure IGP. And I only need one here. So let me move to the egress side. And from here, I need to configure cloud. In here, I want simulating a topology. So let's do a linear topology with 3 nodes. Here you can have a more realistic simulation. Instead of you have a egress connected directly through the emulated node to the DUT, and you can actually configure a different topology. So which in the real network that is the case. So more realistic. So let me finish. So you have 3 nodes, and the router 0 is the emulated router. And then let me add a device group for the RSVP-TE. This will be the egress side. Okay, so by default I have 3 nodes, but I want to have only one egress node. I configured 1. So again, let me name it for the easy reference. So this will be egress topology, and then this is again transit node, and this is a simulated topology, and then this will be a tunnel egress. Okay, now let's configure the IP to match on the other side. So here, my local IP will be 100.1.0.2, and then the other side is actually 100.0.1.1. And after IP, I don't need to configure anything specific for the RSVPTE interface. And then for the OSPF, the same thing here. I need to change the network type as point-to-point, and then move on the simulated topology. So what you can see here is we have 3 nodes, and then the router ID I want to change. So I want to use 3.3.3.1. So I will have a 3 node in the simulated topology. And then you can see the connection here. So the node 1 is connected to the emulated router here, the transit node. And then it's a linear connection. So now on the OSPF side, I do not need to configure anything specific. So let's move on to the RSVPTE egress side. So first of all, I need to configure this loopback address to match with the router ID I configured in the simulated topology. So this one will be 3.3.3.3 because I only want one egress node, the last node in that linear topology. So look at the RSVPTE here. Because I only want to do the egress, so there's no ingress here. And then you can see the tail end side. I have local IP is the 33, and then all the others, I just leave as default. Now I want to configure a RRO on the egress side. So let's say I have 2 RRO objects. So the first one, as you remember, I configure linear topology. So the last node connect to the second to last node. The IP address is actually 3.3.3.2. So So that will be one of my RO, and then the second one, it will connect to the 3.3.3.1. So I want to configure some RO here. So that's pretty much. And as you remember, I also need a PCE components in the back-to-back setup. So let me add another device group and PCE. Okay, so this one is my PCE. This typically is a controller. Now I need to configure the IP. So I will use 100.1.0.3, and then my gateway is the other side of the transit node, which is 100.1.0.1. Okay, and then on the PCE side, and this is just some details on the PCEP session parameter, and then the PCC group. So here, what I need to config is what is the IP address of the PCC. So we know we have 10 PCC configured on the Ingress side, start with 2.2.2.1. Then you can see 10 PCC here. And we do not run the SR RSP. We do not run PCE initiated RSP. So I will put this at 0. Okay, and then this one is for PCE initiated RSP, so we do not use it. Now on the PCE side, we also just make sure the capability is matching on the PCC side. And then we also have a rate control and authentication for the PCE, but that's not our focus for this demo. We are focusing on the PCC emulation here. Now I have everything configured already. So to start the test, you can either do start all or you can start one protocol at a time. So before I start, I want to turn on the capture so I can show you the packet capture for certain PCEP message. So let me start the capture. Go back to scenario. I want to do a start all. So when I do the start all the protocols start together. So you know, it's depending on who comes fast. Sometimes PCC might have session established first, and then RSVPTE might have session tunnel established first. So the RSP state will depend on the actual run. So who is coming up first? I will show you in the capture. Okay, so you can see we quickly have everything up and running, the green. And let's look at the statistic first. So you can see the overall, we have summary stats for all different protocols we are running. And then specifically, if we want to see the PCC stats here, we have a PCC per port. You can see the total PCC session up 10. And you can see all the message transmitted, message counter. And then here you can see how many RSP are synchronized. So we have 100 RSP total. And then you can also see here the RSVPTE RSP goes up. So there are 100 RSP goes up. So you can see all the session, it goes up immediately. So in this sense, the RSVPTE tunnel comes up first, and then the PCC session, PCEP session come up later. So all the RSP will be synchronized as the up in the initial synchronization. Now you can also see the per session stats for each individual PCC session. So this is an on-demand view. So you need a refresh to get the latest stats. So you can see we have a 10 PCC session, and then you can also see at the per session level how many RSP up. Let's look at the capture. So I will look at the PCEP. So this is all the PCEP message. You can see the open, keep alive, and then there's 10 PCC client. and then you see all the PC report message. Let's look at a particular PCC client. Let me do this one, the first one. And then, okay, so here you can see after the PCEP session is up, first you have a PC report message. And then if you look at in the detail here, you see actually the RSP object, you can see the pack bundling here. So as you remember, I configured the 5 RSP per PC report message. So you see the 5 RSP in this one PC report message. If you look at a bit of detail here, so the flag, this one shows the RSP is synchronized as up and active. And then this is the RSP identifier TOI, which shows you this is from 2.2.2.1 with the tunnel ID, RSP ID, and the endpoint egress address. And you can also see the symbolic path name, which is the session name I showed you during the configuration. So this is the first RSP. And then you have another 2 PC report message from this session. So the first one is actually packed. The first one pack another 5 RSP because you have totally 10, right? I say bundle is 5 per PC report, so you need a 2 PC report message. And then the last PC report message is actually end of sync. So you can see the flag here. The sync flag is not set. But if you look at the early PC report message, the flag here, and here the sync flag is set. Okay, that is a quick view on one particular PCC. Now let's move back to the configuration here. So I want to show you some dynamic RSP state change. So as you can see here on the PCC side, it's automatically synchronized all the RSP state from the RSVPTE component. We have inter-protocol communication here. Now, if there's anything change in the RSP state, this will be automatically synchronized to the PCC components, and then the PCC will report that to the PCE. So I want to show you how this works. So let's just pick like 2 RSP here, and then the tunnel is 2 and 3. And I disable it, I do a apply change. So now if you look at the PCC stats here, let's look at the per port stats first. So you can see there are 2 RSP are removed because I removed the RSP from the Ingress side. And then you can also see this from the capture. This is the first PCC, and then you see the 2 PC report message with the RSP remove flag set. So this another one, so 2 RSPs. Now coming back, I want to actually enable this RSP. So let me enable it, and I do apply change. So here, if you look at the statistic here, so this RSVP RSP first signal as going up, and then eventually it's up and running. So you see the 2 and the 2 increment in the stats here. And you can also find out the same from the capture. So first of all, this RSP is going up, and then the first one, the same RSP, which is in the up state, the active. So this is the tunnel RSP2. Now the next 2 is for the RSP3. First is going up, and then the next is in the active state. Now let's show something other interesting thing here. Go back to the configuration. So we also support the make before break for the RSVPTE RSP. We also have the same capability in the PCC to be able to report the state change for the make before break. Let's pick a fifth RSP here. I right click and I say make before break. So now you can see the session info reflected here, saying make before break completed. And then you can also see the states change here. By the way, this is a purport. If you go to the PCC drill down and then you refresh to get the latest stats, you can see all this happening on the first ingress because I'm doing the operation in the first ingress node. Now look at the packet capture. So you have first a report message signal RSP going up. And then you can notice the RSP ID here. Remember, I configured the backup RSP starting from like 30,000. So this is the backup RSP ID. And then you first going up. And then the next one is the backup RSP is up and running. It's active state. And then after this, you tear down the previous one. So now you can see this RSP down, and then this is the original tunnel 5. Okay, now there are, depend on the RSP state. So PCC will report it accordingly. So if you have a PCC session up first, and then you have a RSVPTE tunnel up, you will see the first going up and then be the active state. Have a RSVPTE tunnel is already up, and then you have a PCC session established. Then the PCC will report all this RSP ads up directly. So I can show you that case. Currently we have this running, and I want to stop the PCC. Stop all the PCC. And then let me restart all the PCCs. So you can see all the PCC session is up and running. And now if you go to the capture, so this specific ingress node, after closing, you start again. And then this is the initial synchronization for the RSP report. So you can see this goes up directly. So instead of saying going up first and then the up. So now if I go back here to stop the RSVPTE, I stop the RSVPTE and then start again. So in this case, PCEP session is already up and running, and then you have tunnel start going up. So here, if you look at the capture, so for this particular session, and then the keep alive here, okay. So PCC session stays up. So you will see the when I stop the RSVP and start again, the initial state is going up instead of up directly. So here you can see the symbolically, this is for the first RSP, and then the second RSP, third, and then you have all this. Because bundling is only applied to the initial synchronization. So this is a trigger because when RSP is bringing up, the PCC will report the state in the real time. So each PC report message will contain only one RSP. So after all this, and then you go to the next report here. So see, now you see it's become active state. So this all the RSP are reported as active. You first going up and then become active. So that's all the different RSP state change. And now let me show you the traffic. Actually, traffic is nothing new. It's the existing RSVPTE traffic support. but you can validate the data plan traffic forwarding. So let's add a traffic item, and the source will be the Ingress Node RSVPTE head end. So you can see we actually had 100 RSP, the Ingress RSP. If you do not want generate traffic to all of them, you can change the count here. So I just leave it to all the RSP here. So now on the egress side, we also need to pick the egress. So this is the tunnel tail end. At endpoint. So the packet encapsulation, you can see this is the MPLS encapsulated packet. And I will leave the frame setup and the rate setup as default. And in the flow tracking, I want to track by MPLS flow descriptor. This is pretty useful when you test MPLS traffic. It gives you a lot of information on that specific MPLS flow. So then the preview. So you can preview the generated packet. So you can see the label value and then source and the destination. Finish. Let's start the traffic. Okay, now you can see traffic is running. If you want to see the per flow statistic, so you can see MPLS flow descriptor. This one shows it's RSVP-TE P2P RSP, source and destination, and tunnel ID and the RSP ID. So it's very handy to identify a particular flow. So this is existing traffic capability. So come back as a wrap up. So the current use case we can test is the PCE. We tested the PCE capability for synchronized existing RSVPTE RSP. So you can see all the flexibility we have here in terms of the RSVPTE RSP State Change auto reflect to the PCC components, which will be reported to the PCE in the real time. And then we have a minimum configuration on the PCC, and the only operation you need to do is on the RSVPTE RSP, and then the PCC will automatically pick up the state and report to the PCE. So you don't need additional manual intervention on the PCC side. So that's all I have for today, and hopefully you'll find it useful, and then now you should know how to config a PCEP test for the RSVPTE RSP. Thank you for watching.